All right, today we are talking about solving systems, linear systems algebraically, okay? Last class I taught you how to solve systems graphically. And today I'm going to teach you two other methods. You're not going to use a graph at all, except for on the first example. I'm going to teach you how to solve them using algebra, okay? So again, I got these notes off of flippedmath.com. And if you weren't here last class when I explained it, when I use flippedmath.com, the notes, there's a QRL code in the top left-hand corner. And if you use your phone to scan that code, it will take you to their website. And it has a video of someone from their website teaching this exact same thing. Okay. So if you don't like the way I explain it, we'll go on over to Flip Math and you can have somebody else explain it as well. Coolio? So you have those two options. All right. So it says recall solving systems by graphing. Solve the following linear system by graphing. All right, we know how to do this. That top equation, is it ready to graph?
Yeah.
No. Can we get it ready to graph? Sure. What would we do first? We would, because we're trying to get it in what kind of form? Slope-intercept form. So what is 4y divided by 4? Y equals 2 minus
0.75.
Can I leave it as a fraction since it's going to be my slope?
Yes.
Yeah, I would rather do that. Now, is that the same thing as y equals negative 3/4 x plus 2? Are those the same thing? Yeah, okay. It's just rearranged a little. So what's my y-intercept? 2. So on the y-axis, we go up to positive 2. And my slope is negative 3/4. So if I go up 3, what do? Left 4, but that's not on my graph, so I'd be estimating, correct? So I'm going to go down 3, and in that case, I would go. How many points do I need to make a line? 2. And of course, we use a straight edge because accuracy is important. When you're solving by graphing, you don't just want to willy-nilly throw a freehand line. Is the next equation ready to graph?
Yeah.
Not yet. Oops, not yet. What do I need to do to get it ready to graph? What's my first step? Okay, I can add x to both sides. So we have y equals x plus 1. Now is it ready to graph? Yeah, it's in slope-intercept form. So what do I plot first?
The
one on the y-axis, because that's my y-intercept, yes? Okay. From there, where do I go?
Up 1, right 1.
Up 1, right 1, or
Down 1, left 1.
down 1, left 1. Okay, what's the ordered pair where they cross? Can we see exactly? I mean, we can see where they cross, but do we know the precise location? Would we have to estimate that? What would you estimate it to be? A half, comma, 1.5 maybe, or 1 3/4. Okay, if we use some graphing technology, do you think we could tell precisely what it is? Like if we use, I don't know, let's say Desmos. Let's see, let's do 4y equals 8 minus 3x. And y minus x equals 1. All right, so it looks like ours did. 0.571 comma 1.571. Do you think we would have come up with that precisely?
No.
We were close. We said 1/2 comma 1.5, right? but we weren't exact. So graphing is not always going to be the best method. It's cool if your numbers are small and your two lines cross at a perfect lattice intersection. Y'all know what I mean by that? That's like at a place where you don't have to estimate, you know, like our last notes, everything crossed at a perfect place, or, you know, they were parallel or whatever. But that's not always going to happen. Sometimes you're going to have giant numbers. Sometimes they're not going to intersect at a perfect lattice intersection. So we have to have another method to help us with that, so we can find it precisely when we don't have Desmos to use. You know what I'm saying? Because are you going to be able to use Desmos on your test? No. So it says we need a different way to do it. This is when our algebra skills with a Z will save us. We have two algebraic methods. One of them is substitution. Substitution is best used when one variable can be isolated easily. Okay. The other algebraic method we have is elimination. That's how I like to say it. Elimination. And elimination is best used when variables line up easily. And you'll know what I'm talking about after we do a couple examples. Coolio? Okay. So we're going to start with substitution. And it gives you the steps already typed out. That's pretty cool. Let's try the example above using substitution. Okay, it said substitution is best used when one variable can be isolated easily. So look at these two equations. Solve one of the equations for one of its variables. When possible, solve for a variable that has a coefficient of +1. Does that top equation have a coefficient of +1? No. Does the bottom equation have a coefficient that's +1? Okay, so that's going to be the easiest choice. You can choose either equation and you can choose either variable that you want to solve for, okay? It's easiest if you have a variable in one of the equations that has a +1 coefficient. That's easiest. Sometimes you might have more than one choice. Doesn't matter which one you pick. But if you pick, like, say I picked this top one and I want to isolate the y, when I divide everything by y, that'll turn into 2, but this is going to turn into -3/4. You're going to have fractions to deal with. Who wants that, right? You don't want to create fractions. So it's easiest to pick one that has a coefficient of +1. So I'm going to start with y minus x equals 1, and I'm going to isolate the y. So what would I do? Add x to both sides. So I have y equals x plus 1. So this equation is changed, okay? Now I know what y is equal to. It's equal to whatever x is plus 1, okay? Well, this is called substitution. It says substitute the expression from step 1 into the other equation and solve for the other variable. So if I know that y is equal to x plus 1, and the other equation, wherever I see a y, guess what I'm going to plug in? X plus 1. Don't plug it into the same equation. So instead of 4 times y, I'm going to do 4 open parentheses x plus 1. So I'm replacing y with what it's equal to, substitution, equals 8 minus 3x. Now, do you notice I only have x's in my equation now? There's no y's, okay? So what do you think I'm going to do? Distribute. What's my goal? Yeah, I want to solve for x. If I don't have 2 variables now, I'll just have 1. So I'm going to solve for that variable, okay? So yeah, I'm going to start by distributing. So 4 times x is 4x. 4 times +1 is +4 equals 8 minus 3x. Since I have x's on the left side and x's on the right side, can I get them both on the same side? Yeah, okay. I like to do that first and keep it positive. So if that was my goal, what would I do? Add 3x to both sides. So 4x plus 3x is 7x plus 4 equals 8. Now what? Subtract 4. So we have 7x equals 4 by 7 and x equals 4/7. Now this is the same problem that we graphed above. In decimal form, 4 divided by 7 is 0.571. Isn't that what Desmos said was my x value? Yeah, okay. But if I round it to 0.5 or 0.571 and I plug it into the other equation, it's going to give me a rounded number. So I'm going to stick with the fraction. Okay. So now that I know the x value of the solution, how do you think I'm going to find the y value?
You're gonna remove 4 from the x and then try to solve the y.
Exactly. I know now that x is equal to 4/7. So I can plug that in, substitute it into either original equation or even that new one that we created, and solve for y. So I just substituted into whichever one looks easier. I think y minus x equals 1 looks easiest. And I now know that x is 4/7. So y minus 4/7 equals 1. What do I do to solve for y? So y equals, what is 1 cup of sugar plus 4/7 cups of sugar? 1 and 4/7 cups of sugar. So if this 4/7 is 0.571, wouldn't this be 1.571? Yeah, isn't that what we got on Desmos? They had it in decimal form. So my ordered pair, when x is 4/7, y is 1 and 4/7, or I could say 11/7 if I turned it into a mixed number. Julio? Any questions so far? You want to do the next one by yourself already? Well, you can work ahead of me. You're welcome to work ahead of me and just check with me, but go for it. All right, example 2. Substitution is best used when one variable can be isolated easily. Do either of those equations cannot isolate a variable easily? Well, the top one already has an isolated variable, correct? So sweet. That's when substitution is the easiest. When you already have an isolated variable, heck yeah. So I know what y is equal to. So that means I'm going to start with the other equation. And where I see a y, what am I going to plug in? 2x minus 9. Now listen, there's going to be a lot of mistakes here because a lot of people are going to go minus 3x minus 15 minus 2x minus 9. Why is that not correct?
Because you just take a look at that.
Well, because I am subtracting whatever y is. The whole thing. I need parentheses because I've got to distribute that negative. If I don't distribute that negative, I'm only subtracting the 2x and not the negative 9. That's going to mess your problem up. You see what I'm saying? Y'all see what I'm saying?
Yeah.
Okay. I like when you answer me. Cool like that. Okay, so how am I going to start this? I only have x's now. Distribute, okay? So negative 3x equals negative 15. Distribute the negative. Negative times positive 2x is negative 2x. Negative times negative 9 is positive 9. Hey, on the right side of the equation, don't I have some like terms that I can combine? If they're on the same side, do I change the sign? No. So on the left, let me just clean this up a little. Negative 3x equals. On the right side, negative 15 and positive 9 are both constants. Can't I add them together? What do I get? Negative 6. And then just bring down that negative 2x. Now I have x's on both sides of the equation. I want to get them on the same side. So I can either move the negative 3x over to the right, or I can move the negative 2x to the left. What do y'all want to do? Okay, so how am I going to move negative 2x over? Add it. What's negative 3x plus 2x? Negative x equals. So if negative x equals negative 6, what does x equal? 6. Am I finished with this problem? No, your answer is an ordered pair. You have to find x and y. Sometimes you'll find x first, sometimes you'll find y first. It doesn't matter which one's found first, but you got to find both of them. So now that I know x, what do you think I'm going to do? Substitute it into what? Either of these equations, I'll get the same thing, okay? Because it's the ordered pair they have in common. So I just pick whichever one looks kind of easier, and I think the top equation looks a little easier. Y equals 2x minus 9. So instead of 2 times x, it's going to be 2 times 6. And then just do order of operations. We'll take care of that multiplication first. So y equals 12 minus 9, which is y equals 3. But you want to state your answer as an ordered pair, which would be what?
6, 30.
Is that what you got? Yay! That's what I'm talking about. Questions? All right, number 3. Do either of those have a variable that's already isolated?
Yes.
Already isolated?
Second one.
What's isolated? I need a variable that's isolated.
Yeah.
No, neither of them have a variable that's isolated. Which equation do you think is going to be easiest for me to isolate a variable? Bottom or top? Top or bottom? Okay, if the bottom, what's going to be easiest, the x or the 8y? X. The top, the negative y would be easy to isolate, but it's negative, so I'm going to also have to make it positive. So if you have a positive coefficient of 1, that's just the easiest. Okay, so yeah, I'll start with the bottom equation, and I want to isolate the x. It needs to be the only thing. It's on the left side of the variable or the equation. It needs to be the only thing on the left side. So what do I do? So I get what? X equals negative 8y plus 10. What am I going to do with that? No, because then I want, is x by itself? If I subtract 10, then it's going to not be by itself anymore, right? So I got it isolated. That's the first thing I want to do. Now what am I going to do with that? To what? Okay, this, I started with the bottom equation. So I got to plug it into the opposite equation, right? I can't plug it into the same equation. So I'll have to plug it into negative 3x minus y equals negative 30. So the negative 8y plus 10 is going to be plugged in for x, because that's what x is equal to. Y'all down with that? And I'm definitely going to have to use parentheses because x is now 2 terms. And so I got to make sure I distribute appropriately. Coolio? Now what? Distribute. What's negative 3 times negative 8y? Negative or positive? Positive 24y. What's negative 3 times positive 10? And I didn't mean to write that plus sign there. It just, I accidentally started to write negative. And then do I distribute to this negative y? No, it's not inside parentheses. Bring down everything else. Now, if I have like terms on the same side of the equation, I need to combine those, okay? And I'm not changing the sign if they're on the same side of the equation. On the left side, do I have any like terms I can combine? What? All right, so what is 24y minus y? So 23y, that's all I'm doing right now, just combining like terms, okay? Now, y is my only variable, so I can solve it to equal some number what's my next step? Add 30. So 23y equals 0. Then divide by 23. What is 0 divided by 23? 0. A lot of kids get confused by that. What's 23 divided by 0? Error. What's the actual answer? No. 23 divided by 0. You will get an error message on your calculator, but that's not the answer. What's the answer? Undefined.
Oh, wow.
You can't have 0 in the denominator of a fraction. Can't have it. You can have 0 in the numerator. When you reduce that, you get 0, but in the denominator, it's undefined. How are you going to divide by 0? You know what I'm saying? All right, am I finished with this one? Why not? Yeah, I only know y, what y is equal to. My ordered pair has an x and a y, so I have to figure out what x is. So once I know that y is equal to some number, it doesn't matter which equation I plug it back into, okay? Either one will do. So I'll just pick, the bottom one looks easier. So if y is 0, that's going to be x plus 8 times 0 equals 10. Well, what is 8 times 0? So x plus 0 equals 10. So we know x equals 10. Yes. So what's my answer? 10, 0. Boom. Y'all down with that? Anybody confused thoroughly? Are we okay? Okay, excellent. All right, elimination. I actually like elimination the best. It's my favorite. So previously we said elimination is best used when variables line up easily. Now, sometimes none of this is going to work out for you. You're going to have to manipulate equations to get it to work for you, okay? But elimination's super easy when your variables, everything lines up. So like in this example, my x's line up, my y's line up, my equal sign lines up, and my constants line up, okay? So when that happens, think about it like we're taking the two equations and we're combining them together, like we're adding them together or whatever the sign says. And you want your x's to cancel or eliminate, or you want your y's to cancel or eliminate. That's the goal. Sometimes they'll do it naturally. Sometimes you're going to have to force it. So if I added 2x and negative 3x, would those cancel? Is 2x minus 3x 0? Okay. Look at your y's. Negative y plus y. Would that cancel? So that just eliminated. We want that to happen. If that happens, you can use elimination super fast. Okay. So now just add or subtract whatever each thing says. So what's 2x minus 3x? Negative x. Bring down your equal sign. What's 9 minus 15? Negative 6. I know what negative x equals, but what is x equals? 6. Well, that was easy. Is that my answer? No. What do I got to do?
You have to find 6.
Yeah, I got to figure out what y is. I can plug it into either original equation. It doesn't matter. I'll just choose that top one. And where I see it x, I'll plug in a 6. So 2 times 6 minus y equals 9. And your steps are over here on the side. So if you need to go back and read them. All right, order of operations. 2 times 6 is 12. Minus y equals 9. Then what? Subtract 12 from both sides. 12 minus 12 is 0. Do I have to bring down y or negative y? Negative y equals, what's 9 minus 12? So negative y equals negative 3. What's y equal? 3. So what's my answer?
6.
Is it okay if I said 3, 6?
No.
No. X, comma, y. Cool beans? Y'all down with that? Down with the sickness? The song. It's a song. I'm not talking about COVID. Song. Never mind. Look at example 5. Is everything lined up? Like terms are lined up with like terms. Sweet. If it's not, that's okay. You can rearrange an equation to get it to line up. Okay. But if everything's already lined up, perfect. So will my x's cancel out?
Nope.
Will my y's cancel out?
Nope.
And if your constants cancel, that doesn't help us at all. We need our x's to cancel or our y's to cancel. So just because nothing cancels automatically does not mean that we can't use elimination. We can still use elimination, but we're going to have to manipulate one or both equations in order to get something to cancel out, okay? Using multiplication. So if I wanted my x's to cancel,
No, sorry.
think of a least common multiple of 10 and 3. 30, okay. Could I multiply negative 10 by something to get it to be negative 30x? 3. Could I multiply 3x by something to get it to be positive 30x? 10. So if I multiply the top equation by 3 and the bottom equation by 10, then my x's will cancel. I could do that. Multiply both equations by some number. If I want my y's to cancel, what could I do? What could I turn that plus y into to get it to cancel with 8y? What if it was negative 8y? Would that cancel with positive 8y? What would I have to multiply positive y by to turn it into a negative 8y? Negative 8. One's got to be positive, one's got to be negative. Since these are both positive, we got to get a negative somewhere, okay? So if I want to get rid of my x's, I have to multiply both equations by some number. If I want to get rid of my y's, I just have to multiply the bottom equation by some number, okay? So that'd be easiest. You can pick whichever one you want. I'm going to pick that. You know what I'm saying? So I'm going to multiply the bottom equation by negative 8, every single term in the bottom equation. Now the top equation, I'm not multiplying by anything, but I am going to rewrite it so that everything's lined up. I'm not afraid to write stuff. So I know a lot of kids are like, oh, it's supposed to write. That really wasn't. It took me like 2.3 seconds. So just rewrite it. And then my bottom equation, I'm going to be changing because I'm multiplying everything by negative 8. So what's negative 8 times 3x? Negative 24x. What's negative 8 times positive y? Negative 8y. Bring down your equals. You even have to do across the equal sign. If you don't multiply by everything, you change the meaning of the problem. Negative 8 times 15 is negative 120. Now, will anything eliminate? Yes, positive 8y and negative 8y are 0. If you didn't multiply by negative 8 and you multiply by positive 8, you would have a positive 8y and a positive 8y. Does that eliminate? No, that doubles. Okay. One's got to be negative. All right, let's combine like terms. What's negative 10x minus 24x? Negative 34x. Bring down your equal sign. What's negative 16 minus 120? All right, now what? Divide by what? Oh, I thought somebody said 800 and something. All right, 136 negative divided by negative 34, I get positive 4. Am I finished? Is that my answer? What do I got to do? I got to solve for y. How am I going to do that? Plug in x equals 4, also known as substitute. Does it matter which original equation I use? No. Am I going to get two different answers depending on which equation I use? No, you're going to get the same answer. That's why it doesn't matter. So I just pick whichever one looks easiest. The bottom equation looks easiest to me. You can even use the new one you created after you multiplied by negative 8, but your numbers are bigger, so why would you? But they're equivalent. So if x is 4, and I substitute it in, I get 12 plus y equals 15. Subtract 12 from both sides, and y equals 3. So what's my answer? 4, 3. Julio? Y'all have questions on that? Yes, no, maybe? Okay. Look at example 6. Does everything line up? No. This one, the X and the Y are on the left and the constant's on the right. This one, the X is on the left, but the Y is on the right and the constant's on the right. Can we rearrange this so that the X and the Y are both on the left? What would we have to do? Subtract 2Y. So wouldn't that be 10X minus 2Y equals 22? Do I need to like work that out, or can we just see that? And then the top equation, if I left it like it was, it would line up with now my new bottom equation, right? All right, does anything eliminate automatically? What? Oh, heck yeah. When that happens, that's what you want to happen. That makes it the easiest. So much less work. So now combine like terms. 10X and X are both positive. What is 10X plus X? 11X equals 33. Divide by 11 and X equals 3. To find Y, substitute it into either original equation. It doesn't matter which one. I'm going to choose the top equation. Wherever I see an X, I'll substitute in a 3. And then I'll solve for Y. So I'll subtract 3 from both sides. 2Y equals, what's 11 minus 3? 8. Divide by 2 and Y equals 4. What's my answer? 3, 4. Y'all are good at this. Quite impressed. Okay, look at 7. What is the problem there? Fractions for 1, right? Do y'all know how to clear the fractions? You have to multiply by the denominator. So which one? So 3? 2?
Yeah. Because, wait, no.
How about the least common denominator? Which is what? 6. The smallest number that 3 and 2 will both divide into evenly. If we want to clear the fractions, and I promise y'all, before you leave Algebra 2 this year, you are going to be pros at clearing the fractions. I'm going to see to it, okay? We are not skipping problems with fractions in them. Do you hear what I'm saying to you? Do y'all hear what I'm saying to you?
Yeah.
Okay. We're going to learn this, people. When I have fractions in a problem, I can get rid of the fractions. We call it clearing the fractions. All you have to do is multiply every single term in the equation by the least common denominator. My denominators are currently 3, 2, and 1. So when I say least, a lot of kids pick the number 2. That's not what least common denominator means. Least common denominator means the smallest number that your denominators will divide into evenly. So we said that would be 6. So I'm going to multiply every term in the equation by 6. And I got the feeling from my 4th period that y'all don't know how to cross reduce. Cross reduce? Yeah, but most people are confused by it. So I'm just going to multiply straight across and then I'll reduce, okay? Cross reducing saves time, but we're just going to multiply straight across because y'all know when you multiply fractions, you do numerator times numerator, denominator times denominator, yes? Okay, so let's look at 6 times negative 2/3 x. What would that be before you reduce? What's 6 times negative 2? Negative 12. And remember, there's a 1 under here. What's 1 times 3? 3. Don't forget your x. Yes, it's still a fraction, but will we be able to reduce it in a minute and it won't be a fraction? Okay. What's 6 times negative 1/2 before you reduce? That would be negative. 6 times 1 is 6. The denominator is 1. 1 times 2 is 2. Don't forget your y. Equals, what's negative 1 times 6? Negative 6. Now, let's reduce. What's negative 12 divided by 3? So we have negative 4x. Then what? minus 3y equals -6. Y'all down with that? So I've changed this to -4x minus 3y equals -6. It means the same thing. I have not changed. If I put into Desmos this graph with the fractions and graphed it, and I put in this equation that we just graphed, it would be the same line. Okay, it just looks different. It's like reducing a fraction. 2/4 is the same thing as 1/2, right? They look different, but they mean the same thing. They're equivalent. Now, does that line up with -x equals -11 minus 4y? No. What could we do to get them to line up? If we left this one like it is, what would we do to this one? The -x is already on the left. That part's okay, correct? We would add the 4y. And then the -11, it's okay for it to stay over on the right side because that's where the constant is. Y'all down with that? All right, see what I did? Okay. Whew. This one involves a little bit of elbow grease, you know what I'm saying? So first we had to get rid of the fraction. Then we had to rearrange one of the equations. Now, please tell me either the x's or the y's are automatically going to cancel out. Darn it. If I get rid of the x's, will I have to multiply one equation or both equations by a number? Just one equation. I would multiply the bottom equation by what? -4, because this needs to turn into a positive, right? So if I multiply by -4, -4 times -x is +4x. If I want to get rid of my y's, well, I need to multiply one equation or both equations by some number. Both. So would we rather multiply one or both? One. Can we do both? Yeah, just more work. Okay, you choose. I choose. There. Okay, so I'm going to multiply the bottom equation by what did we say? -4. The top equation, I'm not multiplying by anything. I am going to rewrite it though, so everything lines up. Bottom equation, -4 times -x is +4x. -4 times +4y is -16y equals -4 times -11 is +44. All right, do my x's cancel? Yup. Do my y's cancel? Okay, so we can combine them. What's -3y minus 16y? Bring down your equal sign. And what is -6 and a +44? 38. Now what? Divide by -19. So y equals 38 divided by -19. I get -2. Am I finished? Nope, I have to find x. So I'm going to use that top equation. I now know that y is equal to -2. So I'll just simplify that. So I have -x equals -11 plus 8. It's -x equals -3. So x equals +3. So what's my answer? 3, -2. Example 8. Anybody have questions on 7? Now, if I gave you that problem, I'd probably give it to you as a bonus problem on a test. You know what I'm saying? And if you got it right, I'd be so happy. You get so many bonus points. Look at number 8. Are my x's going to cancel automatically? What could we turn them into? 20. They're both negative right now, so we'd have to make sure one's positive. Okay. Would my y's cancel automatically? No. Could also turn them into 40 or 80. Yeah, but you're just getting bigger and bigger and bigger, right? So why? So 5y and 7y, will they cancel automatically? Can I multiply just one equation? I'm gonna have to multiply both because I'm gonna have to change them both, right? 5 times what gives me 7? I'm gonna decimal. We're not doing that. What could I turn them into? Yeah. 35y, one's got to be negative. Right now, they're both positive, okay? So I have to multiply both equations by something. So to get rid of the x's, I got to multiply both equations. To get rid of the y's, I got to multiply by both equations. Is one easier than the other? It's the same. They're both going to require the same amount of work. So does it matter which one I pick? Well, it never matters which one you pick, but usually try to go with the, when it's less work. It doesn't matter. So to me, 20 is smaller than 35, so I'd probably go with 20. Now, currently my x's are both negative. One's got to be positive. It doesn't matter which one, but you've got to make one of them turn into a positive number, okay? So I'm just going to make my top one turn into a positive 20x. So what will I need to multiply the top equation by? -5. And that's the whole entire equation, right? So that's going to be positive 20x. So what will I need to multiply the bottom by? 4. Y'all cool with that? And make sure the biggest mistake kids make is they don't multiply every single term in the equation. They just do what's on the left and they don't do what's on the right. Okay, don't do that. So let's distribute the -5. I get 20x minus 25y. Y'all tell me if I make a mistake. Equals -5. The bottom, I'll distribute the 4. I get -20x plus 28y equals 20. Now, do my x's cancel like I planned for them to? Yes. If they were both -20x, would they cancel? No, it'd be -40x. Oh, goodness. What's -25y plus 28y? Equals. Then, and y equals. Am I finished? No, I got to find x. I can plug it into the either original or the new ones that I created, but they're just bigger numbers. So why would you do that? It doesn't matter which original. I'll just choose the top one. Numbers look a little smaller. And I know y is equal to 5. So I will substitute a 5 wherever I see a y and simplify. So I have -4x plus 25 equals 1. Now what? All right. So -4x equals, what's 1 minus 25? Then I will, and x equals 6. Now, a lot of students also make the mistake, whatever number they find first, they tend to write that as the first number in the parentheses. Well, that's okay if the first number is x, but we found y first. So is 5, 6 the same thing as 6, 5? What should we write? Cool beans? Any questions? Do y'all want to do this whole page for homework, the front and the back? A good thing. So I wouldn't go make you. Do we have time to do example 9 and 10? Says choose the best method to solve these. Okay, oh my gosh, they have decimals. Is that okay?
No.
We can get rid of the decimals, but really, what would I have to multiply 36.4 by to get rid of the decimal? What? If I multiply it by 10, 36.4 times 10, does that get rid of the decimal? Can y'all see that? Yeah, but can I just multiply that by 10 without changing the meaning of the problem?
No.
I have to multiply every term by 10. So if you want to get rid of the decimal, you can multiply every term by 10. And the denominator, I can multiply that by 10 and get 399, but I'd get 60y and 30y. If you want to get rid of the decimals, you can. Your numbers are going to get a lot bigger. It's not necessary. The decimals, I mean, we can use calculator, right? So it's different than fractions. Fractions, yeah, they're fractions. And if we could turn them into a decimal, but then we might be rounding, and then that's going to change the problem. So we kind of like to get rid of fractions, but decimals, you can use your calculator, or you could clear the decimal by, in this case, multiplying by 10. What if that was like 36.45? What would we multiply by? 100, okay? So you can do that, but calculator, not necessary. So what we're gonna do is next class, we're gonna come in and choose the best method to solve and we'll solve it. But let's just look real quick. On example 9, what would y'all pick? Substitution or elimination? Elimination. Everything lines up, right? If I pick substitution, do either of those equations, either of the variables in the equations have a coefficient of +1? That's going to be a pain. Totally elimination on that one. Example 10, what would be the easiest? Substitution, because I know what x is equal to, I can just plug that into the other one. But if I wanted to rearrange and use elimination, could I? Because I could just subtract 2y and put it over here and get x minus 2y, then it would line up and I could use elimination there as well, right? So next class, we'll come back and we'll do those to kind of jog your memory, and we'll do 11 and 12, and then I'll give you an assignment. We'll have more of y'all doing the work next class, and less of me doing the work. Coolio? So there's no homework tonight, and you don't have a quiz next class. Oh my God. Anybody have any questions? I'll be posting this video on Schoology later tonight for your viewing pleasure. You need to rewatch.
You know that